Okay, so in this video, we're going to talk about modeling with cubic functions, but this time we're going to be using DESMOS to find the model for us. So if you look at your notes, what I've done is I have taken what you've learned in chapter 1, 2, and 3, and I've put them all together on the same page. So this was from chapter 1, and it's been a really long time because we did this all the way back in August. But if you look at the scatter plot of data, it's linear. It has this like straight line pattern. So if you see your real world data with a straight line pattern, what you want to do is you want to use a linear model, okay? Now notice that in your linear model, it looks like slope-intercept form, y equals mx plus b, except for it has this little bitty sub 1 on there. The reason why you have to type in y1 and x1 is because of your table in DESMOS. So when you go to DESMOS and you click on the little plus sign and you start to make your table, it's going to have x sub 1 and y sub 1. That way, your program, because when you type that in, you are literally programming your computer to look at that table of values. Okay, you'll see that in a second. But in a linear model, what DESMOS will give you is your m, which is your slope, and it will give you b, which is your intercept, okay? Now, it may not look like a straight line. It could look like that. It could look like a frowny face or a smiley face, which is quadratic. If it's quadratic, you're going to program DESMOS by typing in standard form of a quadratic equation. You still have to use y1 and you still have to use x1. So today in chapter 3, you're going to have, now this is very obviously like a cubed, like curved pattern. It's got like a down coaster kind of shape to it. Actually, no, this is an up coaster. But sometimes when you're looking at your data, it's kind of hard to tell. But once you create a model for it, it'll draw that model and you can see, you're like, oh yeah, that's definitely the one I need to use. Now, I want you to look at quadratic and compare it to cubic. So quadratic has 3 terms, but a cubic has 4. And the only difference is it uses A, B, C, and D. And it starts out with x to the 3rd power. So it's very similar to a quadratic. It just has an extra term on there because it starts with a cube. The only downfall to this, and this is not fun, but this is not on your formula sheet. So if you forget how to type in the model, if you're taking your benchmark, if you're taking your end of course, nobody's going to be there to tell you, don't forget to use y1. So if you forget to use y1, you kind of have to figure it out on your own. You also cannot use an equal sign. You have to use tilde. And, just make sure on your x's, all of your x's have to be x1. And the only other thing is just make sure, if it's still not working, make sure that your table has x1 and y1. There's been several students today tell me, hey, Ms. Root, it's not working out. And then I look at their table and it says x2, y2. But that's a super easy fix. All you have to do is go back and click on the little 2's and then just change it back to 1's. Okay, so these notes right here, I just kind of took what we've done in chapters 1, 2, and 3, and I threw it all together in a super detailed step-by-step guide on what you need to do to create a model. So you don't have to look back at your notes from chapter 1 or chapter 2. It's literally all right here, okay? So let's flip it over on the back, and we're going to follow along with this example. We're going to type it into DESMOS. And we're going to compare what the book actually has to what DESMOS tells us. So the first thing that I need you to do is just kind of like read the problem, just kind of understand what's going on. It says the data shows the numbers Y of active bald eagle nests. So Y is the number of bald eagle nests so many years after the year 2000. So if T is 2, that means it's 2 years after the year 2000. So 2002, okay? If T is 20, it means the year 2020. So super easy. So X is the number of years, and then Y is the number of eagle's nests. So the first thing you're going to do is you're going to go to your DESMOS, and you're going to click on that plus sign, and you're going to start entering the table of values that they give you. Yes, those are two different tables, but I don't know why the book splits it into two, but you're going to type in one really big table with all of those values. And I'm going to show you a trick on the X values on your time to save you a little bit of time on DESMOS. Okay, so to enter a table onto DESMOS, you're going to click your little plus sign and hit table, and notice how it says X1, Y1. That's exactly what we want. If it doesn't say that, you need to click on that number and change it to a 1. Okay, so if you notice that there's a pattern in either one of your X or Y's, so you see how if you put like a 0 in here and then hit enter, and then hit 2, and then hit enter, DESMOS automatically plugs in a 4 because it recognizes there's a pattern. So if you just keep clicking enter, 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 and I'm like all the way to 16, but notice the next one isn't 18. It actually skips 18 and it goes to 20. So I'm just going to put 20 instead of 18. So if your X values has a pattern, then maybe you can save a little bit of time doing that. Unfortunately, the Y values don't have a pattern. So I'm going to go ahead and type these in. I'm going to pause the recording, and then you stop the recording and type it in and then hit play when you're done. Okay, so I've got all my values entered into DESMOS into the table, but I can't see my data. When you have the home screen, it only goes from like -10 to +10. So what you need to do, let me scoot my graph a little bit over here. You need to click on the little wrench, the little tool, okay? And then look at your X values. Look at your table. What's the smallest X value? What's the largest X value? So it goes from like 0 to 20, okay? So your domain is going to be individual parts between 0 and 20. So I'm going to click on this, and I'm going to change that 0, and I'm going to change this to 20. And the reason why we're doing this right now is because simply clicking on that minus sign isn't going to be the best thing to do. This is way easier, okay? Now the Y's, what I would do is just kind of shoot for something like a really convenient number below your minimum. So like 1,000, okay? And then shoot for a number a little bit bigger than your max. So I'm just going to do like 1,000 to 2,000. And you don't have to go as high as 2,000. You can go to like 1,700. But my point is that as soon as I type that in, I can see the points now. And if you want to click on it and drag it, you can. If you want to hit that minus button 1 time or 2 times or whatever, you see how you can see that data really well now? So all you have to do is just click on the tool and then adjust your X and your Y axis. And it's so easy to do that. So here's where you come into play. You've got to figure out if this is a straight line pattern. Not quite, okay? Do you think it might be a smiley face or a frowny face? No, I don't think it looks quadratic. I do see some kind of like curvy, like a couple of curves in here, so I think it could be cubic. So what we're going to do is we're going to go down to the second line here on DESMOS, and we're going to type in our code for a cubic model. This is the part you have to have memorized on your end of course. And that kind of stinks, but it is what it is, okay? So when you type in Y, you have to make sure you type in Y1. As soon as you type in Y1, it's like, oh, hey, you want me to look at the table that you just typed in, okay? Don't type in equals, type in tilde. Okay, it's in like the top left-hand corner. You have to hit shift. Now, it looks super complicated, but you're just going to do A, X1, nothing fancy, okay? It already knows it's X sub 1, and then just hit your power button. So I like to do shift 6 for power, and then cubic. And it's going to go ahead and start trying to fit a curve to your data, but you need to hit the right arrow, and you need to finish the model. So you're going to do plus BX1, but that's your square. So you're going to hit shift 6, 2. Get out of your exponent. You have to hit the right arrow, and then you're going to do plus CX1. So you just alphabetical order. A, B, C, and that's your linear term. And then you're going to do plus D, which is your constant. And look at your curve. So you can kind of see the overall curve to it, even though you only should be keeping track of your values between 0 and 20. So anything between 0 and 20 is really good for predictions, okay? So here's what you need to do. You're going to scroll it, and you're going to look at those 4 coefficients. Look at your A, B, C, and D. Now, I'm going to change my screen up here, and I'm going to make this really big. I want you to look at that. Look at that on the screen, and then look at what's on your DESMOS. The values of A, B, C, and D. What do you notice? They're exactly the same, aren't they? Okay. I am going to warn you, if you use different apps, like this is not DESMOS, sometimes they could be different because they have different algorithms, and that's okay because the whole point of this is to estimate anyway. So your answer is going to be an estimate regardless, okay? All right, so the whole point of us putting it into DESMOS is that we can find the values of A, B, C, and D. Now look at what they did. Now this is from your textbook. Okay, if you've got a highlighter, great. You don't have to highlight it, but look, 3 decimal places, 2 decimal places, 1 decimal place. Do you see what's happening? And then the last one is an integer, so no decimal places. Do you have to do it like this? No. But I think what's going on with your big ideas, your textbook, is that they want you to go into this pattern, okay? Now, the whole point, once again, is that we've created this model. And sometimes the question just says, create a model, stop, you're done. But a lot of the times, especially in the real world, they're going to ask you to use this model to make predictions. Now, you already have this model in DESMOS. You do. Now, if they want you to write the model, then you're going to have to take A and round it, and then B, and you're going to have to plug it in, okay? So that it looks just like that. But number 4 says use the model to predict the number of nests in the year 2018. So let's go back over to your DESMOS for a second. And what we're going to try to do is we're going to try to figure out where X is 18. So that's the year 2018, right? Instead of you like clicking blindly on this line, go to the 3rd line and just simply type in X equals 18. Like, let's make life easy. So X equals 18, and you see what happened? It created this vertical line where X is 18, and all you have to do is click on that point right there and write it down. So I have 18, and then if I round that, 1562. All right, so what I'm going to do is I'm going to write down 18 and then 1562. Now, this is a little bit different than what you see graphed here. I suspect that what they did is they plugged in 18 into that formula that was rounded. So this is another rounded estimate, but it's just rounded more. So what you're going to do is you're going to say you have about 1,562. We got 1,562. They got 1,561. But it doesn't really matter because you're estimating anyway. Okay, so these are estimates. I highly suggest that you go ahead and you just plug it into DESMOS. Don't plug it into the formula. Okay, so moving on. We're going to use the same model. It is already in your computer right now. And we're going to use 2013. Is 2013 part of my original data? No, it's not. Okay, because 2013 would be X equals what number? 13, right? Okay, so it skips over 13. So what you're going to do is you're going to go over to DESMOS, and you're going to type in X equals 13. And I want you to find the number of nests. It's going to give you a coordinate, but you have to know how to interpret that coordinate. Okay, so I'm just going to simply just change this 18 back to 13. and click on this point right here. Whoop. So I'm going to write down 13, and then, if I'm going to round this nearest whole number, it's going to be 1,499, right? Okay, so 13, 1,499. So let's write that answer in context. So in the year 2013, I'm going to have about 1,499 nests. There you go. That's all you have to do. So just use DESMOS to find the exact point, and then just put a little context into it. Okay, last question on your notes. This one's for you. So I want you to go ahead and clear everything out on your DESMOS, okay? You're going to start a new table. This one's talking about how many pounds of walleye are in a lake years after 2000. So same basic, just not nests. It's just how many pounds of walleye. So what you're going to do is you're going to type that in. Make sure that your table says X1 and Y1. Go ahead and make a cubic model. Write the model down using your A, B, C, and D. And then just make sure, you might want to check with a partner, make sure that you'll have the same values for A, B, C, and D. Or just kind of let me know if you need help, if it's not working out for some reason. And then we're going to make a prediction. Okay, so I've typed in all of my data for the walleyes. And here is my cubic model. And you can see, while it's not perfect, it's pretty close to the line. That model is an estimate. So if I use any kind of predictions between 0 and 20, it's going to be about. It's never exactly that many walleye, okay? So I want you to kind of look at your A, B, C, and D and just kind of make sure that they're the same. And I'm going to go back over to the notes, and we're going to round them using the same method that your text uses. Okay, so A rounds to 0.270. So 3 decimal places on A, 2 decimal places on B, 1 decimal place on C. Now C is a little bit awkward when you're rounding it. It's going to round up to like 83.0. And then D rounds to 111. So if it asks you to write the model, all you have to do is you start out with Y equals. You don't need Y1. Y1 is there just for your computer. And then A would be 0.27. X to the third, that's your first coefficient. And then B, that should be minus 7.44x squared. And then C is 83x plus 111. So that is our model. And sometimes they call it a cubic regression equation. What we're going to do is we're going to use this to predict. And specifically in your notes, it says predict the number of walleye in 2018. Now it's walleye in pounds, but I think you get it. So if we're trying to predict the year 2018, doesn't that mean X is equal to 18 in this case? So you have to kind of think about, what does that mean, 2018? The smartest, the quickest thing I think to do is just to go into DESMOS and type in X equals 18. So go ahead and do that. And you're going to find the point where it hits your model, okay? All right, so I've got the X equals 18. And if I click right here, I don't have to guess. It goes exactly to where I want to look for. So it looks like in the year 2018, I'm going to have about 770 pounds of walleye. So I'm going to go back over here and write that answer in context. And make sure when you're writing your answer, make sure you have the word estimate or about or approximately, never exactly. So there's going to be about 770 pounds of walleye. And that's it.